Well, good morning. So this is Biostats again, and so the when we're meeting in person, the idea of our schedule is that we do lecture on Tuesdays, and then on Thursdays we uh, try to do some things that are active. Sometimes this just means working on our homework and learning about OR. Other times, I have you measure some things, just some simple kind of things. And so I call this day Measurement Day. And so we're going to try to do this online. And so I've got a couple of things planned for you. So the normally I just have you use rulers and a couple other things, and you would measure some simple length measurements on, say, some shells. Get height. The fun activity is I have you throw darts, and so the dart game in particular is a good way to work on thinking about what accuracy and precision means. And it also, all of these can be used to think about the ins and outs of measurement. So we have a chapter on measurement, and the thing about measurement is, of course, that it seems simpler than it actually is. So, for example, one of the things that you can consider is does everybody throw darts the same way, or is each person accurate? And so you throw 3 darts and you can measure them. Okay, but is that necessarily the best measure of somebody's capability? So this gets into the idea that you should do multiple trials when you do measurements. Physiological measures. So heart rate's a fairly easy one to do, right? You just simply take your pulse, blood pressure. We use a device to do that. Body temperature. Okay, well, obviously we're using scanners to do that now rather than to put thermometers in people's mouths. Lung capacity. So I have a couple of ways of measuring that. One is an instrument, and the other is a simple way, is that you just get balloons, and then you inflate the balloon as much as you possibly can, and then tie it off, and then you take the circumference of the balloon, and that gives you then, with a few little calculations, you can get an estimate of your lung capacity, your vital capacity, right? So at any rate, those are the things that we would typically do. And so can't do that now. So what we're going to do instead is we're going to work from some images. So, the old saying, if life gives you lemons, you make lemonade. And so the bonus part about this is that I'm going to show you how to get information, data out of images. And I'm going to introduce you to some free software called ImageJ. Oh, before I forget, I haven't fixed the Canvas page yet, but so things for you to do in relation to our measurement day will be posted by the end of today, and you'll have some instructions about what to do. Sorry about that. Okay, so let's get back. So what I'm going to show you is how to do data analysis on images, right? And so as you can imagine, since microscopy is such an enormously important part of doing biology, people over the years have figured out how to take pictures through microscopes and then how to extract information from those images. Okay, so ImageJ is a free software that was put together by a researcher back in the 90s, supported by NIH, and it's been around for a number of years and has been picked up and supported. It's Java based, if you care about the history. Like a lot of research software, people have added new functions, and so ImageJ is a really powerful image analysis platform, and it's free. Being free means that it's some information about how to run it is available, but some of the detailed information just only happens through trial and error. And so at any rate, here just in the last year or so, well, prior you would have to download it and then install it onto your computer, and that is the best way to run it. You have to install also what's called the runtime environment for Java. And so anyway, there's installation instructions, of course, about how to do that. But back ago, folks have made it available so that you can run it in the browser. So that'll work pretty well for us. You don't have to install anything unless you want to. And so let's take a look. All right. So basically this is our workflow. All we're going to do is we're going to make some linear measurements we just want to go from point A to point B. What's the distance? Okay. And so the workflow is obviously you need to start image J, and so I gave you the website before, and so we would run image J in the browser, right? And so the next thing is, of course, to load the image, and then select what's called the line tool, and you're going to set the scale. So this is one of the important things about doing digital images or analog images for that. If you're going to take measurements from the image, you have to always include a unit scale. And so once you have that, then you can take the image and you can measure that scale and then set that as the global scale for all of your analyses. Once you've done that, you can then go ahead and get measurements off the image, and you save the results, and you have the measurements then in the original units. Okay, so obviously you have to have an image, and so I thought it's not quite as fun as throwing darts in the lab, but we can do pretty close to it. There's obviously lots of online games, and so I found one that's reasonably suitable for this as an alternative. It's at transom.org, maths game darts. Okay, so play the game, save results as a screenshot, and then our unit diameter, obviously it's just a screen image, so we're going to assume it's a standard dartboard size, and so the diameter from here to here is 451 millimeters. Okay, so this is an example of it all running in the browser. This is what it looks like. Okay, and then the next thing we would do is import results into R. All right, so let's go ahead and show it running in R, or running in the browser, image J. So you can see I was just playing some darts. Okay, so just since we're here, select one player, start the timer. Okay, and then you see this thing drifting around, and whenever you're ready, you just go throw. You've got 20 seconds, and so of course darts is about scoring as high a point as possible. But in terms of throwing darts for accuracy and precision, of course what we want to do is get it close to the center. Okay, so at any rate, I would now take a screenshot, and we'll have screenshots like this as part of our example of how to get measures in image J. What we're going to do is we're going to measure the distance between the center and the dart and get that length. The center and the dart, that length, center and the dart, and that length. And we could use that as a measure of our accuracy, which of course is how close is it to the true value, which of course the goal is to get bullseyes, right, every time. And then the measure of precision would be to say draw a triangle here and measure that area. That would be one way to do it. Okay, so I've already loaded this and we're ready to go. So you just proceed to grab an image off of your computer. Remember that screenshot. Oops. So it's shows me doing other things here. Picture, sorry about that. Which one was was it? Oh, I'm sorry. This is embarrassing. Pictures, screenshots. Okay. All right, so there's our dart. That was impressive. Okay. Since it's going to be in your browser, things are going to take a little bit of time. There it is. So remember, what's the first thing we need to do? We need to set our scale. So what I'm going to do is I'm going to select my line tool, and then I'm going to move my cursor to a place. Then you left click and hold, and then drag it across. Release it, and then come up to Analyze, Set Scale, and all we need to do is, this is the number of pixels, okay, but what we need to do is enter in our measure. So you remember how the diameter of a standard target, 451 millimeters, and then we're going to set the scale to global. So that means that all the measures that I take will use this scale, and so then we can close it. Okay, so now I'm going to go ahead and measure my distances, and so just for argument's sake, we'll do this one is the first, second, and third. Okay, and so let's draw our from tip to dead center, analyze, measure. Okay, and so this has lots of additional information which I could edit, but what we want is that one there. So that's 53.451 millimeters. I'm going to move this around a little bit, and let's go back and do it again. Draw my line, measure, there we go, and one last time. Measure. Okay, so now I have my results for this. So I'm going to go ahead and save this, and this is now my data file, and it says results.csv. Okay, let's do darts results. I like to use an underscore rather than space or something like that. And there's a variety of reasons to do that, but go ahead and do what you're normally used to. Click OK. All right, and then let's open that in the folder so I can know where I saved it. Where did it go? Okay, good. It's saved to the downloads folder. Okay. So let's assume that you've already got R installed. So let's try to run this in R Commander. So for my Mac operating system people, right, the R Commander is going to be a window in Xquartz. Okay. So if you go through my quick start in R on the workbook, there's part 1, part 2, part 3, and one of the parts shows you how to load data sets. So that's the bonus point here. We're going to show you how to do that. So you click on Data, Import Data, because we have the data in terms of a text file. That the CSV means column separated. Okay, so from text file. We're going to call it, give it a name, darts. Mostly you can just leave these. Okay. Is there a variable name in the file? Yeah, that's the header, and yes, there was. So local file system, yes. Field separator, we use commas. The decimal point, this is the United States, so we use period. So should be good to go. Okay, so we click on OK, and of course now we have to find it. R Commander's pop-up menus are a little old looking, but you'll get used to them. And so remember, I had double checked where my file was, and it was in downloads. Okay, and what was it? It was darts results. Okay, so we found it, thank goodness. And obviously we talked about setting up a working environment, and for running R, and that would benefit us, right? If we'd set up our folder off the desktop, then I would have moved the data file into that folder, and it would have been easier to find. But this is okay. This will work. So cross your fingers. Let's see how it goes. Open. And if you can see at the bottom of the screen here, R sends you messages. And so it says the data set Dart says 3 rows and 7 columns. Okay, it's been loaded as a data set, and we can click on the view data set, and we are in good shape. Look, we had done 3 darts. It shows all the different measures. The only one we wanted here is this one here. Okay, so I can close this. Doesn't do anything. And now you can run some simple statistics if you wanted. So like summary statistics. Could do, try that. What does that look like? What do we want? We want length. And we can select the statistics, so we can do the mean, standard deviation. That should be enough. Okay? Oh, let's calculate the coefficient of variation. Obviously, we talk about these particular statistics in Chapter 3, so that's what we'll talk about on Tuesday. So I'm just going to apply it, hit OK, and it does it again. And so anyway, here's our measures. It's not very interesting, but maybe we can do a graph. And so a box plot would be appropriate. Length. And the thing in the options, no, we're good. We could change the labeling, but we're all right with that. So we're going to just go like OK. And this is something that can happen, is that especially on a small laptop screen, right? R is going to be throwing new windows up. So you might have to move things around, and there's our graph. Again, we only had 3 data points. This is called a box plot, and so it's not a particularly interesting one. And we'll talk about graphs in Chapter 4. Okay, so what I've shown you today, if we can go back to my computer there, is we showed you how to do a simple image analysis in ImageJ running in the browser. Okay, another image file that I might want you to, I'm going to ask you to work with is to work on I got some shells for you, and so, it's, again, not the most interesting thing, and the picture quality is not the best it could be, so bear with me. Let me go ahead and show you how to work with that image. And again, the point being, set the scale, and then make your measurements. Okay, so let's go ahead and load, so I can close that. All right, and let's open up, and I'm going to close this guy. All right, notice it doesn't ask you to save everything. That's all right. All right, see if I can find this file. Okay. Where did I put it? All right. There it is. Okay. Okay, so 17 shells, conus species, and what we want to do is get the length and the width. This is too small to actually see anything, so let's see if we can zoom in a little bit. And that's interesting. Okay, it doesn't, there we go. Okay, if I scroll, there we go. Okay, so this is, I'm not much of a photographer, it's pretty clearly, it's like, oh, okay, I'll just put a ruler there, that'll work. And I didn't focus very well, and so you could barely see that, and it's like, that's okay. This is, again, this is the idea anyway, but so what are we supposed to do, right? We need to set our scale. And so if you can kind of see that here, this is centimeter size. So, and then the hash marks are in 10 millimeters, right? So at any rate, I can see, okay, so what we're going to do is we're going to draw a line here to here. And that's pretty close, right? Given what I did there, bad image. Okay, so we go to Analyze, Set Scale. The known distance is 100. The units are millimeter. Global. Okay, so we can come back here. Zoom back out. Come on. There we go. Little twitchy in the browser. Okay. And you'll have to kind of play around with this, but what I want to do is I want to get length and then widths. And so it's up to you how to do this. I might be inclined to just go ahead and do length and width for the first one, then length and width for the second one. That's easy. When we talk about doing sampling, you might want to think about randomizing and some other things, but this is our first time around. So we've set our scale. So again, let's draw some lines. And again, you probably want to zoom this in a little bit. Analyze, measure, and there's our length again. Okay, and instead of doing the width, I think I'll just go ahead and measure the next guy. Analyze, measure, and so on, right? And then at the end, what I would do is save, and the default is results. So again, what I would want to call it something else like shells. Okay. All right. Well, I think that's all I've got for you today. So give me till about noon to update your Canvas site, and it'll have a couple of image files. You can, while you're waiting on me, you can go to transom.org and throw some darts and have another cup of coffee. Okay, so thanks for listening.